Hello, my name is Malvika Gupta, and today we are going to discuss a new searching technique which is called index sequential search. We will be discussing about that why it is named as index sequential. Searching, as we all know, it means just we need to find out a particular element in the given list of array. An element could be present in the array, or an element could not be present in that array. So we just need to find out, we are devising a kind of a new solution in how we can search an element in the given list of array efficiently. Before moving to the topic, let me introduce you, let me take you through the tour that what all the contents we are going to cover in this particular video. So the content of this is going to be the introduction, calculation of the block size. I will be explaining you with the example that why block size is needed, algorithm, and the runtime analysis. Okay, so first of all, let's continue with the introduction. So introduction means, before starting with the introduction, as I have told you, the name of this algorithm is index sequential search, right? So searching, we all know, searching means to find an element whether it is present in an array or not. So there could be two possibilities, where either an element is present in the array or element is not present in the array. So we have done this kind of searching, and we know that we have two very frequently used searching techniques like binary search and linear search present with us, right? Sequential search also we have studied. So if searching is there, linear search is there, then linear search is also known as a sequential search. So basically what we are going to do in this, along with the index, we are going to perform the sequential search. It means the basic idea behind this is going to be the linear searching technique, which we are going to perform to search an element in an array, right? What is the use of this index? So let me go through these topics, these points, then I will be explaining you. As you can see in the last point, we will be discussing about the creating the index of an index. So I will be explaining you this one. But before going to that, let me tell you that it will improve the search efficiency. Make sure, just consider this fact that we are only considering the efficiency in case of index sequential and sequential search. So I'm just going to discuss about these two because we have got the name in this particular searching technique as the index sequential search. So might be a reason that we need to compare the efficiency of searching in between index sequential and the sequential search. We perform sequential search, or we are going to perform this index sequential search having this sorted list of elements. So the list of elements which we are going to have, it should be sorted either in the ascending order or in the descending order, and according to that we can plan our conditions. Auxiliary space is required to hold the indices. Now the term this index is considered. If I am having an array of suppose these many elements, 0, suppose 1, 2, 3, 4, 5, 6, 7, 8, these are the elements, 0, 1, 2, 3, 4, 5, 6, 7. This is an array of 8 elements. So what now I am going to do? I am going to create a new array which is called an index array, and in this index array I am going to hold the indices of those indices which is according to my block size, which are according to my block size, which has been defined by me as a programmer, or it has been given by the user because we have asked the user to give the block size, or we have calculated that particular block size according to some calculations that we will be doing, right? So now the question arises, then what is the block size? Block size means that starting from a particular index. So we will be writing here only the starting index, and the block size means that how many element a particular index will be responsible for. It means if I am considering suppose block size as 3, so my block size, so starting index is 0, and my block size, my this particular 0th index is responsible for these 3 values up to second index. The next index will be, indices will be from third. So this will be responsible for 3, 4, 5, I mean 4, 5, 6, right? Or 3, 4, 5th index. Next indices will be 6. It will be responsible for 7. It doesn't matter that we don't have any other value because the array is having this much of limit. So block size we have defined that it is 3. It will be easy for us to have the starting index. Now what will happen? This line if you see, So an auxiliary space has been created. We have an original array, and on the basis of that original array, we have defined another array which is called an index array, which is having 3 elements. So the indices will be like this, right? In the other searching techniques, whatever you have studied like binary search, linear search, we have never discussed about an extra space. But here in index sequential search, we are taking care of an extra space, right? So now the last line, it says it does the indexing multiple times. Now you can see that this is the first time I'm doing the indexing, but if you see, I am doing indexing for the second time. That is why it is written over here that it does the indexing multiple times. It means creating the index of an index. It has created the index of an index. You see 0, 3, and 6. These are the indices of this original array. And to access these indices, I have created new indices 0, 1, 2. So this is like index of indexes, right? So I have created indices of indices. It means that in index sequential search, I am not going to perform or access the elements directly from this array. Whatever the element or whichever the element I want to access, I need to access it through this particular index array. So if I am writing, if suppose I wanted to access this element, so how I am going to write? I will be writing it like this, because I have to access it from this side. So it will be like this, that index 0, right? So index 0 is going to provide me the value which is 0. So if you see a of 0 is what? It is 1. So you will be having this. So it means that we have to take time. Firstly, we need to access it from here, and then we will move to here, right? I hope this is clear to everyone. So this is how we are going to perform the index sequential search. Now the question arises about this block size. I have told you that this block size could be either a programmer defines this block size, or you're asking from the user to define the block size as per his or her convenience. But if not, if you wanted to do some calculations, so as you know that we did this kind of calculations in the jump search also. Jump search also we need that how many or what block, how much of the jump the pointer should perform, whether it is of 3 or 2 or 4. It's like that, right? Now the question arises that what block size a user should consider, right? Suppose this is an array of n elements, right? So I am giving the indices like this, right? Now you can consider, like, if suppose if you wanted, if you are a programmer and you wanted to give the block size as per your convenience, so what how much what is the block size you can consider, or you ask the user to give that particular block size. So make sure, suppose if you have given the block size bs is equal to 1, bs is equal to 1 means you are taking the entire array. Entire array means that I am going to perform linear search. So what, there's no point of creating a new index array and then performing that linear search concept, right? So because we do have this kind of searching technique available with us, we are frequently using this, so there's no point using this one. Secondly, it will be like suppose I have given this bs is equal to 2. It means that I have divided this into the two parts. So if you see, this is already a sorted list of elements. In sequential search, it doesn't matter whether it is sorted or randomly organized, but if you see for the binary search concept, an array should be sorted. So if you could see over here, it is a sorted list of array and you have divided this array into two parts. So what will happen? It will perform like a binary search. So again, there is no point to perform it because we have these two searching techniques available with us. Now, so it's like that we always, whenever we are defining the block size, we are giving the accurate block size, so it should always be greater than 2, right? Always we see that. But now the question arises that if suppose I wanted to take it, like I wanted to derive a particular solution, that how to define this block size. So you can do one thing. Suppose if this is the size of an array, which is, suppose n I am taking as the number of elements, or you can say that size of an array, and m I am considering as the block size. That in these many blocks I wanted to divide my array. So how I am going to do this? It's a simple mathematics. You know that n by m. N by m will be defining your block size. That in these many number of block size, you will be getting your array divided, right? Now the question arises, what will happen in index sequential search? Because it is a combination of indices. Indices, we know how we will be defining the indexes. But now the question arises, how we are going to use the sequential searching techniques. So what happens if suppose in this particular array, if I see that I have divided this block into three parts and I have to search a key element which is 4. So what will happen? I have to first check with this first index that if the value of my key is less than this particular value, then I will move ahead to the next index. Next index is 3. If the value of my key element is less than or equal to this particular element, then I will move to the next one. So if you see that it is the element, suppose I am going to find for 5. 5 is less than equals, 4 is less than equals to 5. Oh, sorry, 5 is less than equals to 4. So condition is false. Again, I will move to the sixth index, next index. 7. 5 is less than equals to 7. Yes, your condition is true. So what will happen? You have moved to this particular index. What you will do, you will come back to the previous indices because this value is here, the condition gets true. It means you are not supposed, you are not going to find your element beyond this because it is a sorted list of elements. So it means majorly there is a chance that you will get your key element present in this particular portion. It might be possible that this element is not present in this, but whatever will be the output, it will depend on these three elements. So what I am going to do now, you see, we'll be applying here the linear search concept. We'll be comparing each and every element, and if the element is found, then we will return it by saying that element has been found, or if not, then we'll say the element has not been found in this particular list. So how much time it will take? If you see how many comparisons I have to make, so I will be making m-1 comparison. This is the size of block size, right? So block size, I am taking n is the total number of size and m is the block size, because according to the block size we are working. So m-1 number of steps I have to perform just to get it. So if you see, so I can like this. This is for the linear search in that particular block, and this is the process of dividing my entire array into the blocks, right? So now my question arises that how this is the calculation of block size and how I am going to calculate. But now the question arises, and in this particular calculation, you will be able to get the runtime analysis also for the index sequences. So I will be taking both the things together. Now see, because this is my statement, that's how I am going to do this. This much of time will be taken by the algorithm to divide the entire array into n number of blocks, and this will be time to search an element in a particular block. So we need to minimize this. We know that for the minimization of the process, we will be having a technique, a mathematical technique, which is called differentiation. So what I'm going to do, I'm going to differentiate this entire process, entire equation using this differentiation, right? With respect to m. Now, if you differentiate it to this one, so you know that this differentiation is easy. You all know this. This will become f-1 plus m-1 and equals to 0. If you differentiate it this one, then it will be like n by m square plus m will become 1 and minus 1, because this is a constant, so it will become 0, right? Now you can see this one. If I'll go to this side, then minus m upon m square plus 1 equals to 0. I'm taking this on this side. So suppose I have changed it. Now you see n equals to m square, so m equals to under root of n. So m I have considered as my block size, so I can find out my block size by using this square root of n also, the concept of square root of n. This concept we have already used in the case of jump search. How this is working, because index sequential search is more or less similar in working, but the only difference is that in the jump search we are not having any auxiliary space to store the jump indices, but here we are accessing the original array using the index array, and that indices can be defined by using this concept, right? So if you see, this is the entire time which I am going to take, so my complexity will be order of under root of n. I hope this is all clear to everyone, right? Okay. So next we will be moving towards the example, and with the help of this example, we are going to design the algorithm. Okay. So first of all, we just understand that how we are going to make it, right? So before starting with this one, let me first write the indices over here. I'm going to write the algorithm according to this. So step by step, we will be taking care of the algorithm. Okay. Now, before starting with this one, we have to take some certain cases. I'm just talking about case number one. Case number one means that if your, because this is a sorted list of elements, right? Sorted list of elements. If you see that it is a sorted list of elements, so natural is this, that case number one says that if in the original array, your indices at 0th index, the value of key is less than your 0th index value, it means it is lying in this particular region, out of bounds. So it says that the element not. The case, I hope this is clear to everybody. It means that we are searching for that. Like suppose if key is less than my a of 0, right? This is that situation. Next one, case 2. Case 2 says that, this is case 1, I have written. Case 2, I am taking this one. Suppose my element, I'm just considering it, we will be writing it in the algorithm, but before that, I'm just telling you how to do this. Case 2 says that if my last index, an minus 1 value is, key value is greater than this one. So it means it is beyond this. It is not lying here. So in that case also we can write element not. We all know this. These are the boundary cases. We just need to fix the boundary. If suppose this is the condition, right? Now this is case 3. In this case 3, we have two situations. Either element found or not. Both the conditions could be true. Any of the condition can be true in this situation. Either element could be found or element could not be found, but whatever the condition we have to follow, if the element is lying in this, under this case 3, so we have to perform this particular section, right? So these are the three cases which we need to discuss. So case 1 and case 2 I have already told you. Now what about case 3? How we will be moving with this? Let's see. Now if you see, total number of elements is 9. So first of all, we need to create an index array, right? Our first task is to create an index array, and for that index array, we need to decide what is the block size. So first of all, before moving ahead, let me write the algorithm also. So I am doing index sequential search where I am passing an array, okay, in elements and the key value which we have to search. So let's decide which element we wanted to search. Suppose I wanted to search 28. My key is 28, which I wanted to search, right? Now next, first step says that I have to calculate first the block size. On the basis of, based on that block size, we are going to create an index array. So block size is equal to square root of n. That we have already created, n suppose. Okay. Now my block size has been created. Now what next I have to do? I have to create an index array. So I am writing this index array. So it is 3 according to the under root n. So my index array will be here. Index array, I am writing it. Okay. So block size will be 3. So my first index has to be 0. We all know that. My second index has to be 3 with the block size, because block size is 3. And the next index will be 6. I know this. But how to do it? How to perform it in the according to the code? So what I am going to do, I am going to take a loop, an extra variable, which I am going to set it as 0. Now, in the third, I am going to create an index array. Okay. So this is my index array. How to create it? So let's do it. For I equals to, I am taking it from 0 to n minus 1. The entire array, entire process I am going to do, but the steps which I am going to do, the increment or the updation which I am going to follow is according to the block size, because my first index has to be entered is 0, the next index to be 3, and the next index will be 6. So it means 0 plus 3. So first of all, I am going to write 0 over here, then 0 plus 3, 3 is over here, and then 6 over here. So let's see how to do that. So I'm writing I equals to I plus bs. Okay. And then I am writing index x plus plus equals to I. Now see how it will work. I'm just taking care of this one. Okay. So how it is going to work? If you see algorithm, this is the step. I'm writing this index step over here. Now you see I equals to 0, I is less than n, I equals to I plus bs. So that will be easy for you to understand. Index x plus plus x was initially 0 equals to I, right? Now first time when loop will execute, because this is a post increment, so first of all it will take x as 0. So my first index is 0 index. Index 0, what is the value? I equals to 0. Yes, this true. So the value will be stored as 0. N is 9, so it will go till 8. Is it clear from here? I equals to b plus I plus bs. Now bs is 3, I was 0, so now my new index will become 3. 3 is less than 9, condition is again true. Index, now it has been incremented by post increment, so x has become 1. So index of 1 is equal to I, which is 3. So the next index will be, the values stored is 3. Next I move to, so it will become 6. 6 is less than 9, again the condition is true. X has become 2 and the new values stored is 6. Next time, when I am just going for the I, it will become 9. 9 is less than 9, condition is false, and we come out of the loop. So that's how we have created this index array, right? Now, the question is, before moving ahead or before doing the searching technique, we have discussed the two boundary cases, case 1 and case 2. So I'm going to discuss about those two cases also. So first of all, we will be writing the condition for those two cases, that how those two cases are going to execute. So let's see how we will do with those cases, right? Now see, first case is if my key value is less than my A of index of 0. Okay. If this is the condition, it means this shows that my key value is 28. Suppose my key value was 5. So 5 is less than index of 0 is what? 0. This, I hope you understand this one, this concept. This is, if you have not understood, please look into this. Index of 0 means index of 0 means 0. So it is A of 0. A of 0 means 12. So if you compare now, key is less than 12. So my key is 5 and 12. So 5 is less than 12. So my first value, it is in the sorted order. So it actually means that there will be no value which is going to be less than this value. So this, in this case, we will be directly writing it as element not found. So because we are going to use the concept of function, so what I am writing here it as return 0. I hope this is clear to everyone. Now the next one. The next part I am going to take as the boundary condition. If suppose my key value is greater than, because I am going to just make sure that you are accessing this original array with the help of this index array. So whatever you are going to do, just make sure that, right? So index and x minus 1. Okay, now see, because we have started with this one and we have created this, so my x will be the length of this index array. So x is 3, total number of elements is 3. Just always remember this, that x is equal to 3, right? So we will be taking my x minus 1 is 6. So if I write it 6, and if the key value is greater than this one, it means that it is not going to lie in this particular array, right? So what I am going to do, I am just writing here also return 0. I hope it is clear, right? Now 6th step. Now it has been created. That case 1 we have discussed, case 2 we have discussed. Now it's the time for case number 3. That if my array is present, if my element is present in this particular array. So what I am going to do now is just writing a for loop. I'm writing this for loop for what? Now you need to understand that for which we have to start with this for loop. What do we have to do in this one? I mean, we have to consider the entire length, or we need to consider only the indices. So just now understand this concept, that we are going to access the original array with the help of this index array. So it means that my loop will move from 0 to x and do. Okay. So what will happen now if my key value is less than or equals to, it might be a condition that the element will be lying on that particular index, is less than equals to index of I, like this. If it is happening, right? This is the condition. Now see what will happen. I'm writing this here. For I equals to 0, I is less than x, I plus plus. This is x. I'm writing the condition. If key is less than equals to a of index of I. Now try to understand this one, that what we are going to do. So first of all, I is equal to 0. So I'm writing it over here. My key is 28, which is the value which I am going to search. 28 is less than equals to a of index I. I is 0. So here it is 0. Now see, index of 0 is what? It is 0. The value at index 0 is 0. So it will become 28 is less than equals to a of 0. What is the value at a of 0? It is 12. So it will be like 28 is less than equals to 12. Condition is true or false. If the condition is false, then I am not going to move inside the statements written over here. What I am going to do, I am going to move to the next index. See, I am moving on the index, this one. I'm not moving towards this one. Okay, so my pointer will now move from I equals to 0 to I equals to 1. So it will become 1. Now again, this is 1. Index of 1 is what? 3. So I am going to write over here 3. What is the value at A3? It is 21. So if I'm cancelling it out and 21, I am going to write it. 28 is less than equals to 21. Now condition is again false. So if the condition is again false, it means that I have to increment and I will move to the next state. So my I will become 2 now. So let me check with index of 2. What is the value at index of 2? It is 6. So I'm going to write it 6 over here. A of 6. What is the value at A6? It is 57. So now if you see, 28 is less than equals to 57. Yes, the condition is true. It means it is not possible for me to find out this particular element in this block. So what we will be doing, we will be moving to this index. Okay, how I am going to move from this particular index to this index? Just I need to, because sixth index was stored at second position and third index was stored at first position. So just simply what I have to do, I have to decrement my I value to minus 1. I have to decrement my I value by 1 only. So it means if this condition stands true, then I have to move back and set my start pointer here and my end pointer till here. And in this particular block, I have a chance to get or to find this particular key value, right? I have to search only this m minus 1 elements. So how I am going to write this part? I'm writing it over here. You see, you can check from here. So suppose I'm taking index as start. So I am setting my start as how? My start will become index I minus 1. So if you check in start value, so start will be like equals to index I minus 1. My I was 2. So it will become index of 1. At index of 1, what value I was having? Index of 1, I am having 3. So my start is actually equals to 3. Now, the last indices which I want. So natural is this, that my next index should be 6, because less than 6 I have to run m minus 1. So it means I have to run for 3 times. So m, total number of m, but because we are going to run it from 0 to m, so it will be like 0 to m minus 1. So if I write end, then end what it will be? End is equal to what it will become? Start plus PS, because we have PS. So if you see start plus BS, start is 3 plus BS is 3. So your end will become 6. So it means we are going to search it with till here, right? But when I am going to apply the sequential search concept, now what will happen? This is, I have got this one. Now, once I get it, I will break from this particular loop. I'll come out. I will come out of it from the if condition and from my loop. If this is my loop, I have come out from this. And seventh point, I'm going to apply the sequential search function. I'm not going to discuss sequential search over here because that you know. Array I'm going to pass. I'm going to pass number of elements and the start index because I need to define that how many number of indices. If you want, you can also ignore this part also, but just send this start and end because you are not going to search the element in the entire array. You're going to search that element in this particular block, right? So start, end, and that key which we wanted to search, and then we will be having that sequential search performed. So this is the end of the algorithm, and at the end we will get the output. Okay, so if you see from here that we have designed, so I am having an array which is like this from third index. So if you say 3 4 5, because the loop will go from, if I consider the loop, so loop will go from less than m, or you can say that less than end. So it will be end minus 1, which will be 5. So if I see, the elements will be 21, 28, and 36. 21, 28, and 36. So it will be like, if I am writing over here, start. So my loop will start from I start. If I consider this sequential search like this, that array I have passed, start I have sent end, and then the key. So if I am lighting the loop, so my loop will be for I equals to start, I is less than end, and I plus plus. So what will happen? It will keep on searching in this particular segment that my A of I is equal key. Okay, so if it is true, flag equals to 1 I am doing. If I'm setting flag is equal to 0 over here, and break. And at the end, after this loop, I can write it like that element is found. If flag is equal 1, then it means element has been found. If flag is equal to 0, then element has not been found. It means the value of flag has not been changed. So if you see A of I, it's A3. A3 is equal key, false. Next, A4 is equal key, true. So what will happen? I have make my flag is equal to 1 and then break out of this, and just I can write that yes, my element has been found at this particular location. So this is all about the index sequential search. I hope this is clear to everyone. This is the difference between the index sequential search and the sequential search. That first of all, as we know that we only require the sorted list of elements, and in the sequential search we need random elements. In this, both random and sequential access is allowed. You have seen this, how the random access has been done. You can see this, that we have just made the indices from there. So from that index, we are not supposed to go for the sequential one. We were accessing the elements through this. So if my element was there in the block, the block started with the third index. So what I have done, I have just came back to third position, and then sequential search I have applied in this particular block. So that's how this will work as both random and sequentially. In fact, in sequential search, we all know that it will go sequentially. We cannot skip a particular element. We have to check each and every element. Here we have calculated the time complexity, which was order of root n. Here the time complexity order of n, which is higher as compared to this one. But here if you see, we used to do that, this searching technique in the given array, but here for searching we need an extra space. So it will be having a space complexity, which we have considered for order of x. So this is all about the index sequential search and how it is different from the sequential search. I hope this is clear to you all. These are the references to which you can go ahead, and thank you.